Hello student, I am Dr.A.K. Today I am going to discuss nomenclature of elements with atomic numbers above 100. Then I will try to explain all the things by asking some question, then you will understand faster. Then here one question is there. What would be the IUPAC name and symbol for the elements with atomic number 120? You have to write IUPAC name and symbol for the element with atomic number 120. How will you write? Common all are knowing sodium, potassium, calcium, magnesium, hydrogen, all things they can write and they are knowing and that if 1 is there then it is hydrogen, if 2 is there helium, 3 is there lithium, 4 is there beryllium, 5 is there boron, 6 is carbon, then ordinary they can write. But now above 100, how will you write? This it is difficult. This is difficult to write. Before giving the answer, before giving answer of this question, you have to understand some fact. Only then you can answer. Then now what are the problems in doing nomenclature that I am going to discuss. After that quickly without delaying you can write. Not only 120, many you can write. You can't remember, only you can write. You can quickly you can write. I will tell you some these things, rule and regulation. After that quickly you can write. Then now first to listen the you can say why IUPAC has given some direction in naming the elements greater than 100 atomic number. Then first you listen. After that and after listening all the things you can answer very quickly. The naming of the new elements had been traditionally the privilege of the discoverer for those who have discovered. In their name it was given and the suggested name was ratified by the IUPAC. In recent years, this has led to some controversy. The new elements with very high atomic number are so unstable that only minutes quantities, sometimes only a few atoms of them are obtained. The synthesis and characterization therefore requires highly sophisticated costly equipment and laboratory. Such work is carried out with a competitive spirit only in some laboratories in the world, because laboratories were very less sophisticated and costlier equipment was required. Laboratory was also very less. Then such work is carried out with a competitive spirit only in some laboratories in the world. Scientists, before collecting the relative data on the new element, at times get tempted to claim for its discovery. For example, both American and Soviet scientists claimed credit for discovering element 104. Both were claiming. The American named it as a Rutherfordium, whereas Soviet named it Kurchatovium. See, 104 was discovered. Then both claimed. American called or named it as a Rutherfordium, whereas Soviet named it Kurchatovium. To avoid such problem, the IUPAC has made recommendation that until a new element's discovery is proved and its name is officially recognized, a systematic nomenclature be derived directly from the atomic number of the element using the numerical code for 0 and number 1 to 9. This is the numerical numerical roots. What are the roots? The numerical roots for 0 and number 1 to 9. I will tell you. This is the recommendation given by IUPAC. That name must be given according to the atomic numbers of the element using the numerical roots for 0 and number 1 to 9. What are these roots? I am telling now. Okay. And one more thing here before this root, one thing again you should know. The roots are put together. The roots are put together in order of digits which make up the atomic number and IUM, just like calcium. IUM you are writing in the end. Calcium, potassium, rubidium, cesium, IUM. Then rule is that first you write this roots for 0 and numbers, and then at the end you write IUM. That's enough. That is the, you can say, nomenclature of the new element above 100. Now first you understand the roots, then easily you can write. Actually this, suppose it is 111 or 102, then for 1 you write what is the, this is the digit 1, then for the digit 1 what is the root, that root you have to write, and again 0, for the 0 what is the root you have to write, and for 2 again what is the root, that you have to write, and after that at the end IUM you write. Okay, now just try to understand. I am coming for the root, numerical roots for 0 and numbers 1 to 9. Here just listen carefully. For 0, name has been given. Actually what I am going to discuss, that is the notation of IUPAC nomenclature of elements. Then digit 0, its name is nil. 0 means nil, NIL, and abbreviation means only in one digit, a small n you can tell. First letter only, NIL. Then N, first letter, that is the abbreviation N. In a shortcut only N you can write. For 1 it is UN, UN. Then for that abbreviation is only U, first letter. And for 2, bi, bi, then abbreviation is B, first letter only. And after that try, TRI, then first letter T is the abbreviation shortcut. For 4, quad, Q-U-A-D, quad. Then abbreviation is first letter Q. 5 is called pent, P-E-N-T, pent. Then abbreviation is P. 6 is hex, H-E-X, hex. Then abbreviation is H. 7 is sept, S-E-P-T, sept. Then abbreviation is S. All are a small letter, S. 8, oct, O-C-T, oct. Then abbreviation is O, a small letter. All are, what I told, all are a small letter. 9 is N, E-double-N, N, N. Then abbreviation is E. This I have told you. This you have to remember. This you have to remember, and only then you can do the nomenclature. Again, one more time, I am telling you. 0, for 0 it is a nil, means a small n you can write. For 1, UN, un, then abbreviation is U. For 2, bi, means B. 3, tri, means T. 4, quad, means Q. 5, pent, means P. 6, hex, means H. 7, sept, means S. 8, oct, means O. 9, N, means E. Then here actually I think almost all think you might have heard nil. You know, nil means always 0. You are knowing, and that is easy to remember. 1 and 9 is somewhat new. The 1 is UN, means U. That you have to remember. And after that in the middle you might be knowing bi, tri, quad. Quad is 4. Quadrant, that it came from that. And all things are again pent, hex, sept. For 7, sept. That S letter. And 9 is somewhat new. Oct also, you know, 8 means oct, O. Only 9, E-double-N, N. That you have to remember. 9, E-double-N, N, that is a E. If you are knowing all the things, then easily you can do these things, nomenclature. Now I am giving some examples. Okay, after that automatically all will do. Very easy, very easy. Okay, as for example, 101 atomic number. So 101 atomic number, its nomenclature, what will be the name of the element? Very easy, you can do. For 1, you write UN. For 0, just to continuously you write, just like a spelling you are writing, September, October month, or anything, spelling, like that way, just to write. Anything, either you are writing elephant, E-L-E-P-H-E-N-T, like elephant, you write like that. Then here 101 is there. Then for the 1, you write UN. For the 0, you write NIL, nil. And again 1 is there. Then again you write UNI. That's enough. 3 digit you have written. For the 1, UNI. For the 0, you have written NIL. And again for 1, UNI. And I told you, and the end you write IUM. Then now we have done the nomenclature. To spell this thing is difficult, but you can write very easily. Now, symbol. How will you write the symbol for this? Then just like for calcium, Ca is there. for potassium, K is there. For lithium, Li is there. Sodium, Na is there. Like that way, its symbol is just U and U. U and U. Okay. Like that way, nomenclature is very easy to write. And official name for this 101, what I told you now, that is generally it is given by in the name of scientists who have discovered or sometimes native place. But officially what there has been done, that is important. Okay, then officially this is called Mendelevium MD, popularly known as Mendelevium MD. But IUPAC name I have told you. Okay, like that way. Second example I am giving 102. Again same way. For 1 you write UN, for 0 NIL, and for 2 BI by, and in the end you add IUM. Correct? Then now its symbol, it U and B. Shortcut you can tell. Its symbol is U and B, and it is known as Nuvallium. Nuvallium, NO, N and a small O, NO, just like a Mendelevium. MD is there, this is the NO. Like that way, 103 also. For 1 and 0 again write same way. For 1 UN, for 0 NIL, for 3 try, and in the end for the 3 this thing TR. For the third TRI is there, that you write, and IUM write, because here 2 times I is coming, then you write only 1 time. Okay, continuous 2 times I is coming, you write only 1 time, but you have to write trium. Then now its symbol is UNT. Symbol is UNT, and it is called Lawrencium, LR. Symbol is LR, scientist name. But they are also official, Lawrencium, LR. Like that way, 104. Again same way, UN, NIL. Now for 4, quad, QUAD, quad. And again in the end, IUM. And its symbol is UNQ. UNQ. In periodic table, you will see this name only. If you see the periodic table, then you will find only this symbol. And separately, if you write, I will tell you later on, then this official name also you can write. But if nomenclature they are asking, according to IUPAC, like that way you have to write. Then 104, that is a Rutherfordium, RF. Like that way, 105. Then again for 1 UN, for the 0 NIL, for the 5 you write pent, and in the end I write IUM, and its symbol is UNP, and official name is Dubnium, that is the DB, capital D, small b. Next, Rutherfordium also RF, capital R, small f, second letter always small. Now next 106, then again same way, for 1 UN, for 0 NIL, and for 6 hex, HEX, and in the end IUM, and its symbol is UNH. Symbol actually again they are taking one letter from each roots. For the UN, U letter they have written. For NIL, N letter they have taken. And for hex, H letter. Then three letter they have taken. Then it became the symbol. In everywhere, same thing is there. Now 106 I told you, this is actually seaborgium. Seaborgium, official name is seaborgium, SG, capital S, small g, SG. Like that way, 107. Then again 1 means UN, 0 means nil, 7 means SAPT, IUM. This is the IUPAC name. And again 3 letter, what is 107? 1 you take. For the 1 U, and for the 0 nil is there, only N you take. And for the 7 SAPT is there, only S you take. Then this 3 letter is making symbol. And its official name is borium, BH, borium. Okay. Now again 108, same way. For 1 UN, for 0 NIL, for 8 oct, I, and last IUM you have to add. Again, then what will a symbol? 1 letter you take. U, for the UN, U, for the 0, 1, for the nil, only 1 letter N, and for the octium, only O. 3 letter you have to select from the every digit. Then it became UNO. And official letter is, official name is Hassium, that is the HS, Hassium. Now 109, same way, UN, NI, and for the 9 you write ENN, IUM. And symbol will be again for 3 letter, for the UN only U, for the nil N, and for the these things, for the 9 E, it became UNE. And what is its official name? Official name is metrinium, metrinium, MT, metrinium. Now like that way 110 is there, 110. Then 2 times you write UN, and for the 0 NIL, and the end IUM. Then again you take 3 letter, for the 3 digit, 1 letter, then UUN. And official name is Derma Stadium, Darm Stadium. Okay, just like a cricket stadium. Yeah. Darm Stadium, DS, Darm Stadium, DS, symbol, IUPAC symbol is DS. Like that way 111, like that we write 3 times UN, UN, and the end IUM. Then its symbol is very easy, U, and the end IUM you have to write, that is common. Then this became U, and its official name is Rond Gentium, RG, capital R, small g. After that, this 112, same way you can write 112, 113, 114, 115, 116, 117, 118 you can write, but official names are not declared. Official name after 112, after 111, up to 111 is there. 112 onward, it is not declared. Okay, that's why it's a official name, and IUPAC symbol has not been, you can say, declared. other things it related to this, that the new elements first gets a temporary name. As soon as they will discover, scientists will discover, they will give temporary name. Thus the new element first gets a temporary name with symbol consisting of 3 letters. Later, permanent name and symbol are given by a vote of IUPAC representatives from each country. The permanent name might reflect the country or a state of the country in which the element was discovered, or to pay tribute to a notable scientist, those who have discovered. Sometimes on his name, element name is given. As of now, elements with atomic number up to 112, 114 and 116 have been discovered. Okay, up to 112 it is discovered. 114 is also discovered, 116 is also discovered. In the middle gap is there. 113 is not there, 115 is not there. Then as of now, elements with atomic number up to 112, 114, 116 have been discovered. Elements with atomic numbers 113, 115, 117 and 118 are not yet known. But in periodic table, a scope has been given up to 118. But 113, 115, 117 and 118 are not yet known. Now what I asked the question in the beginning, what would be the IUPAC name and symbol for the element with atomic number 120? Now easily you can write usually. Then what will be this? Then symbol and the you can say symbol you can write for 120. For the 1 you write U. For 2 you write 2, that is for by B, UB, and for 0 N, UBN, and this is the symbol UBN, and then name. Then for the 1 you write UN, for 2 you write BI by, and for 0 you write NIL, and in the end IUM. This is the name and symbol. Name already told you now, and symbol also I told you. One letter you take from their these things, 1 to 0. For 1 I told you UN, for 2 by, for 0 nil. Then one letter you take, then it will be symbol. And name I told you UN, BI by, for the 2 by, and for 0 nil, and the end IUM. Then now I have discussed about the these things, about the nomenclature above 100. Again now I am discussing these things, some new things, that is the electronic configuration in periods. Electronic configuration in periods, and again I will discuss after this group wise electronic configuration. 2 things I will discuss now, after that I will stop. Okay, then electronic configuration in periods I am going to discuss. Already I told you period. What is the period? Period, you know, yesterday I told. What is the other name of period? Then Other name of period is valence shell. Valence shell. And period may be first n is equal to 1, that is the first period, n is equal to 2, then second period, n is equal to 3, third period, 4, n is equal to 4, fourth period, n is equal to 5, fifth period, 6, n is equal to 6, then sixth period, and n is equal to 7, seventh period. Only in seventh period, whatever 118 elements are found, in that some are not found, but all are accommodated. And what are the orbitals required to adjust all electrons? 118 means 118 electrons. And chances are there up to 118, no doubt at all, only they have not discovered. Then these, to adjust all 118 elements, elements, how many orbitals will involve in that? Then just already I told you, s orbital, p orbital, d orbital, f orbital. This is sufficient to, you can say, adjust all 118 electrons. 118 electrons that can be adjusted by use of only this S, P, D, F. If you will fill electrons, then all 118 electrons can be accommodated or is accommodated, you can tell, only in this S, P, D and F orbitals. Okay, this is, I told you, from the concept point of view. There is there, G is also there, H is also there. This is just imaginary. If you can say more electrons will be found, then that time they can be used. That is a hypothetical, theoretical, imaginary. Now next things you should understand, again very conceptual, and question is asked, difficult question, that is come under the difficult question, that the number of elements each period is twice the number of atomic orbitals. This statement you keep in mind, very useful. The number of elements in each period is twice the number of atomic orbitals available in the energy level that is being filled. Means if how many orbitals are there, just their double in that period, number of elements will be there. This question will be asked like that, how many they will give the number of orbitals, then they will ask how many elements will be there in that period. N will be orbital. If you are knowing the orbital, then you can know the number of elements in that period. Number of elements in that period already you know. Then when n is equal to 1, then maximum these things, this will be 2. Correct? Only 2. In the first period, only 2 elements are there. In second, 8. Third again, 8. And 4 and 5, 18, 18. Correct? And 6th, 32. And 7th, it is incomplete. Then now you can tell by knowing the orbitals, number of orbitals, just to make it double, that is the element. As for example, suppose Why it is double? First you understand why it is double. You know that in each orbital, in each orbital, in actually in period, in any period, or new orbit will not open. Only in that orbitals will be filled. Just remember, very important things. In any period, new orbit will not start. Only electron will go in the same, you can say, orbit. Under the same orbit, all will be filled. No new orbit. Correct? Then here, example I am giving for S. First period n is equal to 1. Then there you know that only one orbital is there, that is the s orbital. Then s has maximum 2, s orbital maximum capacity is of 2 electron. Then you should also know that in whole periodic table, one electron is increasing and they are giving new name. As for example, when they got the element in that only one electron was there, then they have given the name hydrogen. When they got another element, new element in that, when they saw that, oh, in this 2 electrons are there in outermost orbit, or simply you can tell 2 electron they found. They got a new element and that 2 electron was there. Then they considered new element as a helium. Like that way, if they found that okay, now 3 electrons are there, then they have given a new name lithium. Then when they got in a new element, they got okay, 4 electrons are there, then they consider as a beryllium. New name they have given, means a new element. Like that way, 5 electrons, when they discovered that 5 electrons are there in the new element, then they were told boron. Like that way, for carbon 6 they got, 7, 8, 9, like that 118. Then this number of electron actually is called atomic number. Then you see that for every new electron, new element is there. That's why in the first period, 2 elements are there. One S1, that is the hydrogen, and second is helium, 1 S2. And here again I want to tell you very important things, that 2 and 8, and the end of a nomenclature you will write, then S is equal to 2 means now completely filled. In first period, maximum 2 electron, that is the helium. Helium, this is exception also, helium is stable and is kept in group 18. All stable elements are, means end of the period. All periods ends are stable. Then only helium is in exception. They are stable only in 2 electron. All have octet, 8 electrons. All got, and the end you will see, then sp. In each period, last will be sp, means 2 plus 6, 8 electron. Then 8 electron is stable, and the last, in the last orbit, if 8 electrons are there, then that is called stable, and all elements will be very, very less reactive. you can say non-reactive. Also can tell inert gas. Inert gas. Then this I told you about the stability. Then helium is 2 last. This is only exception, only in 2 it is satisfied, stable. And all have 8 electrons. And they are becoming stable, means S and P is there, NS2, P6. In every last, all are periods, and the end they have NS2, P6. Okay. Then now you can, I was telling about that how it will be double, then concept just in mind you think. Because question, several type of question will be asked on this concept. Then first I told you period 1. In period 1 only 2 elements are there. Why only 2? Then because S1 and S2, S orbital is there. Then in first there is possibilities for 2 only, because maximum capacity of S is only 2. Then S1 first element. Now if another electron will come, then it will go to the next. Then it is a S2. Hence S1 and S2. S1 means one element like hydrogen, S2 means another element like helium. Then in the first period only 2 elements are there. Correct? This is the double of S. Orbital is only one, S orbital. Then make it double 2. Because in any orbital, I told you, in any orbital only 2 electrons can accommodate in any orbital. Correct? Then here S is there. Like that, S means maximum 2, then it means 2 element. Now just you come to the P, means you know that Px, Py, Pz. Then 3 orbitals are there. If P is there, then 3 orbitals, Px, Py, Pz. If D is there, then 5 orbitals. If F is there, then 7 orbitals. Then in each period you count how many orbitals are there and then make it double. That is the elements present in that period. Now I am giving period 2 example. Period 2. Then there in period 2, there what will be there? S and P will be there. Only 2 will be there. S and P. Then S means 1 orbital. P means 3 orbital. Then total 4 orbital is there in P is equal to in period number 2. In period number 2 only this S and P are there. Then S means 1 orbital, P means 3 orbital. Then total 4 orbitals are there. Then 4 make it double 8. That's why 8 elements are present in period 2. Period 3, 3 orbitals are present. S, P, D. In this also, this I told you second and third. Here also period 3, S, P, D are present. Then here also S and P. Second period and third period S and P are present. Correct? Then here again same things. S and P means 3 plus 1 4, 4 into 2 8 electrons. Then I told you 2 8 8. Now come to the third orbital, fourth orbital. Then fourth orbital, S is also there, P is also there, and D is also there. And S, P, D, 3 are there. Then for S again, 1 orbital, P 3 orbital, and 5 D 5 orbitals. Then 5 plus 3 plus 1, 9 orbitals are there. Then how many elements? 9 into 2, 18 elements. Like that way, fourth and fifth, same way, 18, 18. Because number of orbitals found in fourth and fifth is 9. Like that way, sixth, 6 now F is there, extra F. Then you know F means 7 orbitals. Already told 7 orbitals. Then this add also 9 plus 7, 16. 9 plus 7 means S, P, D, F. S means 1, P means 3, D means 5, F means 7. Total 16. And how many elements? 16 into 2, 32. That's why in 6 it is 32. Correct? And 7th is incomplete. Then I have told you how will you come to know that how you can tell how it is coming. You can say this total number of elements in any period. How will you calculate? I have discussed this. How will you calculate? Calculation to calculate number of elements from orbitals present in that period, easily you can calculate. Now next things that what is the, you can say, transition series, that you should understand. Transition 3, total 3 type of series are there. D series, D series, 3D series, and 4D series. Actually, in D, in the name of D, 2 are there. 3D and 4D transition series. Transition series of elements. 3D and 4D. Okay. See, in the name of orbital, D orbital both are there. D series only. But there are in group, in a period you will see, in period that is 3D. When you will start 3D and 4D, then here you have to understand actually what happens. Electrons in electronic configuration, if how electron fills, then first it will go to S. S is less energy. After that P, and then if P means all three, Px, Py, Pz will fill, then it will go to the D. D5s are there, 5 orbitals, it will go to there. This is the sequence, how electrons will fill the different orbitals. But here some exception is there. That is very, very important. All questions are, exceptional question is asked. Then what is the exception? That sometimes what I told is sequence. First electron will go to S, it will fill. After filling, it will go to the P. In P also 3 are there, Px, Py, Pz. After filling P, it will go to D. There 5s are there. Again it will in a sequence way, dxy, dyz, dzx, x dx square minus y square, dz square, means 5 orbitals are there, they will fill. Like this is the sequence, normal way. But sometimes they will, actually one principle is there, off-wow principle. Off-wow means build up. Then they follow this off-wow principle. Off-wow principle is that filling of electrons according to the energy level, increasing atomic energy level. Then exception will be, what will be exception? That I told you it should go from P to D. After filling it should go to D. But sometimes what will happen, that just it will open, you can say, uh, more orbital, means big orbital it will open. Sometimes I am giving example, 4s will start without filling 3d. After 3d 4s should come. After 3d 4s should come. Then according to the general rule it will go to the 4s without filling the 3d. Then only you can say in the new orbit which started like 4s, then maximum it will go either 4s1 or 4s2. But after that, after filling 4s or 4s1, it will not go for the 4p. Before going to the 4p, 3d is vacant completely. 3d is vacant completely. Then they will fill this 3d. Then 3d capacity is 10. It will start from 0 to this 10 electrons. D have capacity for 10. Hence 1 to 10 it will fill. 1 to 10 it will fill. That's why these 10 electrons 3d have. Before going 4p, they want to fill 3d. 3d is vacant full. Then these 10 electrons are called transition elements. Transition elements, 3d transition elements. And why the term transition? Because it comes in between the S and P. P has started, just started P, and S is completely filled. In the middle, in third period, 1s1 means up to 1s2 is filled. S, it is coming between S and P. Then that's why it is called transition. Coming under S and P, this is called transition elements. Okay, because D was incomplete. Now after filling 4p, until they will fill all this D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, means all are different elements. We see the periodic table. Periodic table I have attached a long form of periodic table that you can, or modern periodic table you can see. In the middle is the D. In the middle is the D and F. D and F. Okay, F block elements are in the middle. Okay. Then that's why 3 and 4 also is there. 3D transition elements and 4D transition elements. Then two transition elements I told you, 3D and 4D, each have 10 members. Why 10 members? Because D1, D2, D3, 1 they are filling. 1 they are filling, then 10 electron means 10 elements. 10 electron means 1 they are filling. It's 10 elements. Then 3D and 4D is called transition elements. 3D and 4D transition elements. And two more series is there. That is called inner transition series. What are that? Then that is F, because now electrons will begin to fill. What I told in the same way, D is filled. Then D is filled, but F without filling, without actually F it distance without filling F, new orbit started. Inner they have not filled and new they have started, like S, what I told you. Then F will be, D and F both will be, I can say, not fully filled. Sometimes D may be filled, but F will be incomplete, not filled. Then just like D I told, now it fills, F also begins to fill. That's why it is called inner. Because F is not filled and next orbit is opened. But it is just started. Just started. S only, generally S will start. New orbit S will start. Then inner is not filled and new is started. Then in this case, D and F both will be, you can say, incomplete. Then both has to fill. That's why it is called inner. Inner transition elements. And here, what is their importance? Main things that here a photovital has 14 capacity. That's why each will have 14 elements. Each means like 3 and D, I told you 3 and D series, transition series, 3 and D, 3 and 4 transition series. Here 5 and 6 are there. 5F and 6F. 5F inner transition series and 6F transition series. Then 5F inner transition series, just like actually one is called when 4F and 5F. 4F and 5F. In 4 only this starts. F orbital start only from the 4. Then 4 and 5. Then here 4F inner transition series, 14 elements are known as lanthanides. 14 elements are there. And 5F, which is also 14 elements, that is 5F series is called actinoid series. Actinoid series. Then now I have told about the total 4 series. Okay. Now I am going to tell about the this group-wise electronic configuration. Group-wise, just like I discussed only period, according to the period. Now I told you in period new orbit will not start. Only in that, under that whatever is there, electron will go. New orbit will not start. Orbital may start inside of that, within that orbit, within that orbit, whatever orbitals are there, that can start. But new orbit will not start. But here in group, now I am going to discuss group-wise electronic configuration. Then here what happens, that you listen carefully what are the group-wise electronic configuration, that I am going to tell. Elements in the same vertical column or group have similar valence shell electronic configuration. Again, I am telling you, elements in the same vertical column or group have similar valence shell electronic configurations. The same number of electrons in the outer orbitals and similar properties. They have same number of electronic configuration in the outermost orbit. That's why their chemical properties and physical properties will have similarity. Okay, This is the special about the group-wise electronic configuration or group group-wise or in a group. I told you whatever elements are there, in that elements all group will have some similar type of chemical and physical properties. For example, group 1 elements. Group 1 elements is called alkali metal. Alkali metal group 1, just like hydrogen, hydrogen is gas. Lithium, sodium, potassium, rubidium, cesium, francium. Francium is radioactive. All in the last seventh period, whatever elements are there, all are radioactive. Then francium is last of the first group. Lithium, sodium, rubidium, cesium, francium. Then all are actually are the member of group 1. Group 1, lithium, sodium, potassium, rubidium, cesium, francium. All are the members of group 1 and this is called alkali metal. Alkali means soft. Other is in group 2, that is called alkaline earth metal. Alkaline. Then in that two elements you will find in every you can say in group members, their group members are there: barium, magnesium, calcium, strontium. This thing beryllium I am talking about. Start with beryllium, magnesium, calcium, strontium, barium, radium. Radium is radioactive. These are the members of group 2. Then all these two group I given examples, they have and the last orbit two, you can say first group 1 means S1 and the last all are having only one electron, S1. Okay, period may be changing. Here period will change. New orbital start. In each group, if you go down, this period, new period will start. Correct? Period will change. But this S1, one electron only you will find in a new period. Last orbit will have only S1, each one electron. Like that way in group 2, S2 you find up to the last, up to the radium, two electron, S2. But orbit will be changing. In group orbit change. But in period it will not, this way orbit will not change. Okay. Then example I given for the group elements. First the group 1 elements are called alkali metals. All have NS1 valence shell electronic configuration. And in group 2, NS2. Everywhere last will be NS2, means 2 electron will be there. S is common. In group 1, that's why it is called group 1. And NS2 electrons are found in the second. That's why NS2. 2 is what is given due to that. Valence. It is talking about the valency or valence. Okay. Thus, it can be seen that the properties of an element have periodic dependence upon its atomic number and not on relative atomic mass. See, question is asked that properties, chemical properties or physical property depends upon what? Atomic number or atomic weight? Then correct answer is atomic number. Okay. Today I am stopping only here. In the next class again we will meet with the next topic. Thank you.